Okay, we're going to take a look at a problem that is very similar to problem 22. In 4.2, it has to do with linear modeling, and it has to do with a pair of jeans being sold at a certain price corresponding to a demand of a number of pairs of jeans at that price. So it makes sense that there's a linear relationship here, or at least a relationship where as the price goes up, the demand for jeans would go down. See here at $22, it's 60 pairs in a day, and then here at $32, it's 44 pairs in a day. But we're going to go ahead and walk through all the steps, and these should be the same steps as when you would do problem 22 in the book. So I did go ahead, and so that the video wouldn't be too long, I went and drew myself a graph here, and I also already plotted the scatter plot. That was the first question. It says, well, actually the first question says, does the relation defined by this set of ordered pairs represent a function? It turns out the data itself is not a function. It is a relation, right? We got this mapping from price to demand for jeans, but it turned out that on 2 different days, the same price of $25 corresponded to a different number of jeans being sold. So the original data is not a function, although we're going to try to map or find a linear regression line that models this general trend, and that regression model itself will be a function. So I already answered A down here that it is the original data is not a function. But then it asked me to draw a scatter diagram, and I did take care of that right away. I went and put my axes together, and I started here. I skipped a little bit because my first data point was at 22, and so I didn't want to go ahead and start way out here with 20, and so I did this little jagged line saying that I'm going to start here at 20, and I did the same thing here, starting here at 40. So I didn't have to count all the way up to 40 and then get my graph started. I'd have a big gap. But I also plotted the points, and this is called a scatter diagram, and I think that part is pretty straightforward. For example, the point 2260 would be over here at 22, and this horizontal axis is the price of jeans, and this vertical axis would be the demand at that price. And so at $22 we had 60 pairs demanded, and I think I'll just go ahead and label that y-axis also as demand. Okay, let's go ahead and do part C then. So it says, use the graphing utility to find a line of best fit that models this relation. So this is where we're going to go ahead and actually try to enter this data into the calculator. So let me get my calculator here. And this may be your first time trying to go ahead and input data into the calculator. So what we're going to go ahead and do, the first thing, is I'm going to go ahead and go to stat, right here, stat. Let me turn the light on the projector here. Let me see if that'll help us a little bit. See the calculator a little better. And so I hit stat, that's right here, and then I choose edit, and that's going to bring up my table where I could put in lists of data. Now I already had some data in there from some other problem, so let me show you how you clear a list. I'm going to go over here for list 1, I'll go up to L1, and then I'll just hit clear, and that is right here. Let me show you. Right here I hit clear, and then I down arrow, and that clears that list. And I go over here, I go up to L2, I hit clear, and that clears that second list. So now I'll left arrow over, and I'm going to begin to put this data in, and I'm just going to go right down this list right here, and this would be 22, 24, 25, 25, 29, 31, and 32. Okay, so I have my list of prices, and now I'm going to correspond it to the list of jeans being sold in a day at that price. So there's 60, 57, 56, 53, 52, 49, and 44. Okay, we're good. Okay, so we have our data in there, and it did ask us, it said, use the graphing utility to find the line of best fit. So now we're going to go ahead through that process. So what we're going to do now is allow the calculator to help us calculate that linear regression line of best fit. So I hit Stat. I go over to Calculate, right? And I choose my model. On this video, we're looking for linear regression because this data seems to be behaving linearly. You know, you'll have later problems where you fit other kind of functions. For example, you see here among my list, I have all kinds of regression options. But I'm going to pick number 4, linear regression, for this problem. So I hit number 4. And now I want to go ahead and eventually, once I find my regression line, I'd like it to map over into y equals. Because in that way I could also draw the actual line through the calculator, the regression line that I'm trying to fit to this data. So I'll show you how you could store the regression line over in y equals 1. So I go down there, and then what I'm going to do is I'm going to hit vars. And I want that to go into y equals, so I want y vars. It's a function, so I go ahead and hit enter. And I want it to go into the first option. You know, if I hit y equals, you'll see you have options for a whole bunch of equations, right? I'm just going to go ahead and put it into y sub 1. So I hit enter. So it's ready to map it over, but we haven't calculated it yet. So I'm going to go down here and hit enter for calculate. And there are my coefficients and my constant in a y equals mx plus b equation, which is the standard form of a linear equation. So I could go ahead and copy this down here, but it's also mapped over fully. I'm going to round off as I just write down my answer, but the full decimal places that you see here are going to be in y equals, which I'll show you in a minute, but let me get this copied down. So this is my answer to C. So I have y equals negative 1.3355x plus, let me move this over a little bit more, plus 88.8684. I just went out 4 decimal places. Okay, so I have that. All right, now the next question is, it says, interpret the slope. Well, don't forget what we have here. We have demand on the y-axis, right? We have demand on the y-axis, and we have price on the x-axis. That slope should be a change in y over a change in x. This must be the change in demand per change in price. So if I looked at this here, I'm answering part D. My slope is this. If I created a fraction to be per 1, so what this really is I have a loss in demand, okay? So I'm going to go ahead and have, I lose 1.3355 pairs of jeans in sales for every $1 increase in price. And you can see what's happening as it goes down here, right? Every time I go over $1, I'm really losing some demand in, which makes, practical sense from a standpoint of just, when people see a higher price, they're going to tend to buy less, right? Okay, so we go ahead here to E. And E says, express the relationship that we just found in part C in function notation. So let's think about this. This is price, so I'll go ahead and represent that with P. This is demand. I'll go ahead and represent that with D. And by the way, this has already been identified up here in the beginning of the problem. So in the book, when you do problems like this, look in the original wording of the problem and take a look at how they define the variables. Take a look here. Even in the original wording of the problem, it mentioned that demand was going to be D and let price be P. So what I have, if the x-axis is my input or my domain values, and the y-axis is my output, right, or my range values, I have demand as a function of price. And x really represents price, the x-axis. So I'm going to say that in function notation I have this. And here's my function of demand as a function of price, right? Okay, so let's see what F says. So F says, now, what is the domain of this function? In other words, over what prices does this function make sense? Well, there's going to be a point at which we're not going to be able to sell any genes. I'm sorry. There's going to be a price at which, we would have an astronomical number of genes being sold because when you aren't charging anything, everybody wants some. But there's also going to be a price at which we're going to go ahead and have a demand of 0 over here. So we're trying to come up with that domain set of values, right? That where do we go ahead and end up with as we approach 0? How many genes would we sell? And where would the demand for genes be 0 as the price gets too high? So what we could do to come up with the place at which we would go ahead and not have people wanting to buy genes because the price is too high, we could just say, well, where would the demand be 0? Let's set this function equal to 0, and we would have this. And we're going to go ahead and solve this. And this is going to be our upper limit of our domain. It'll be the price at which we don't have any demand for genes. So I'm going to go ahead and subtract the 88.8684 to the other side. I'm going to go ahead and divide by negative 1.3355. And that answer approximately turns out to be $66.54. And we're just going to go ahead and round that off. I mean, well, let's think about this a little bit. If we went to $67, we'd have a negative demand, right? It would go below, right? It would go below a 0 demand. And so let's just go with $66. And so we're going to say that's our maximum. So as we look at this, let's look at our domain on a number line. We're going to go ahead and say that we don't want to be any more than $66. And we want to be greater than $0. I mean, if we make it 0, then we would have probably, that's just ridiculous, right? So we want it to be greater than $0. So our domain values for the price would be anything from $0 up to $66. That might be it. Let me take a look here. How many genes will be demanded? Or one more question. How many genes will be demanded at $28 a pair? Well, that's a domain value, right? That's a price. So I'm just going to do this calculation right here. I'm going to put 28 into my function. And I would be really calculating D of 28. And if I put that in there, I would have this. Plus the 88.8684. And if you did that calculation, you would end up with at that price, a demand of 51.474, or approximately 51 pairs of genes.